Hi, welcome to this webinar that is offered by Flamco. I'm Sophie Keloganian. I'm responsible for the technical training for hydronic flow control, so Flamco and COMAP. This presentation deals with how to avoid sludge formation in the heating network. So the overview. First, let's talk about the sludge and the causes of the sludge formation and the consequences regarding the heating network. Afterwards, I will explain the solutions to reduce the sludge. So the network design first, and second, the solutions regarding the air. Indeed, you will quickly see that the sludge issue is closely linked to the air introduction into the network. Then the description of the Flamco technical solutions. To go further, a word about the water quality inside the network, and at the end, a conclusion. So let's start with the causes and the consequences. I suggest to start with the consequences in order to get aware of the issues. First, a fouling issue within the boiler, as well as for the radiators, which means that that's not comfortable anymore for the tenants. The sludge may also clog the pipes, so there is a loss of energy and an overconsumption. It's estimated that the sludge causes an extra consumption of 18% of energy for the boiler and 27% for the heat pump. The sludge also causes pumps and valves wear, may block the valves. In doing so, there is more maintenance, of course. The estimation is 30% added maintenance actions when there is sludge, and it's estimated that there are 30% of the network in Europe that are full of sludge. So a lot of money spared because of maintenance trips and extra energy consumption. If we want to find solutions to avoid sludge into the network, we must know the origin of the sludge formation. First, there is the water composition. The water is full of dissolved salts, and they may induce scale deposition. It's less true currently because the filling water is mainly a soft water or a demineralized water, so without mineral salts inside. An important cause of sludge is the corrosion by the dissolved oxygen. It creates iron oxides, such as magnetit, and other metal oxides, from copper and aluminium, for example. Don't forget that there are also other types of corrosions. There are many types of corrosion, but we can talk about acid corrosion and galvanic corrosion. All of them produce metal oxides and sludge. They can be avoided by the way to design the network and the water characteristics. I think about the pH, for example. And last but not least, when the temperature is not too high, there is the bacteria development. And something very important is that the bacteria needs oxygen to grow up. The conclusion is that the main cause of the sludge formation is the oxygen into the network, so the air enclosed inside the network. In addition to the sludge, the air is responsible for many problems in the network. It's in the case if you are not convinced by the corrosion and the bacteria development. So the other issues due to the air, first, the bad heat circulation. Indeed, the air blocks the water circulation. Don't forget that the air is also highly insulated. It makes noise, it's gurgling in the radiators. The presence of air may damage the pumps and the valves because of the cavitation. There is also erosion due to the bubbles that run with the water. It induces instability in the control valves settings and generates extra energy consumption because of the balancing. That means the pressure and the flow are not correctly set anymore, and because the air is heated for nothing. As you can see, beyond the sludge formation, there are many reasons to focus on evacuating the air from the network. So what are the solutions? There are three solutions. First, on the left side, the preventive solution. The preventive solution is paying attention to the network design and avoiding air porous material when building the network. The second solution is a proactive solution. That means preventing the air to enter into the network and get out the air from the network. We talked here about the air that is already in. And the third solution is waiting for the sludge formation and getting out the sludge from the network. But that means, in that case, that there is no equipment to evacuate the air. So all the issues we have just talked about will occur. So first, a word about the network design. If it's a new building, pay attention to the products you install. Indeed, think about the multi-layer pipe that contains 100% oxygen barrier thanks to the aluminum layer. If you want to install PEX, the necked PEX doesn't contain an oxygen barrier. So that means the oxygen can easily go through the pipe and dissolve into the water. But if you select the 5-layer PEX pipe, that means there is an oxygen barrier and inside, and almost no oxygen can go through the pipe. The remaining concentration of oxygen into the water will be 0.1 milligram per liter. It's lower enough to avoid problems. So regarding the hydronic flow control products, think about multi-skin, the multi-layer pipe system, and about the pentapert, which is or biopert, which are 5-layer pipes. So with an oxygen barrier. So now, don't forget also that regarding the total cost of the building, 30% is the construction cost and 70% is the maintenance cost. It will be interesting to reduce the maintenance cost, of course. So now let's talk about the air. We want to avoid air intakes and we want to evacuate the air that is already in. So first, we have to understand the different forms of the air into the network. There are 3 different forms of the air into the network. So that's the first point. First, the well-known form is the microbubbles or the air pockets into the network. They are mainly located at the highest points of the network. The second one is the microbubbles. The microbubbles flow with the water and they don't create air pockets when the network operates. And the last one is the dissolved air that we can't see and that flows with the water. So as there are 3 different types of air inside the network, we need 3 dedicated pieces of equipment to catch the air and evacuate the air from the network. So another question is, what are the air inlets? Where are the points of entries for the air into the network? The air is initially present inside the network before filling the network with the water. As the pressure is getting higher when one fills the network, it's estimated that the air content is 2 times more important after the filling process. A big part of this air is dissolved into the water. So it's the first point of entry. The air is already inside. Think about the water itself. The filling water and the top-up water are full of dissolved air. If the water, of course, is not degassed before filling the network. As you can read, the water naturally contains oxygen, about 10 milligrams per liter, and nitrogen, 18 milligrams per liter. We talked about porous materials, that can let the air to go through. All the connections, such as pumps, valves, fittings, thanks to all that points of entries, the air can continuously dissolve into the water. Some defective air vents, and if the expansion vessel is not correctly sized, the air can get in from the high points of the system. And as the pressure is very high, into the network, the air concentration can be very high into the water and may reach 50 milligrams per liters. So it's necessary, it's very important to remove the air, to focus on the air and to remove the air from the network. So now let's talk about the technical solutions to remove the air. Many people think that installing air vents is enough. I'm afraid no, and I'm going to explain why. First, an overview of the technical solutions linked with the kind of the air form we can see in the network. First, for the micro bubbles, the air vent, you can see a flex vent and a flex vent super on the side. The air vent works only if there is an air pocket. That means when it's possible to form an air pocket at the highest point. So it's almost only when the water is quiet, so when the network doesn't operate. And also, that means also that during the winter, during all the winter season, the air vent doesn't operate because there is no air pocket formation at the highest points of the system. Regarding the microbubbles, as I said previously, run with the water. So the air vent can't trap the microbubbles, and we need an air separator that can catch the bubbles from the water and create an air pocket and evacuate the air pocket thanks to the air vent we can see at the top of the piece of equipment. Regarding the dissolved air, we need a degasser. The degasser operates as when one opens a bottle of sparkling water. The pressure drops from the bottle pressure to the atmospheric pressure, and so when the cap is removed, and as a result, a lot of bubbles form and can be evacuated at the top of the degasser here with the air vent. The degasser can be used for the feeding water and for the top-up water also. I'm now going to describe the technical solutions. So first, the automatic air vent called FlexVent. So we said that it's a product that's unable to evacuate the air pockets. So the FlexVent, the small air vent, is dedicated to the domestic installations, and the FlexVent Super is dedicated to the boiler room and the big installation. Something very interesting is that it can support minus 0.2 bar, so that can avoid the air suction at the highest point of the installation. The functions of the air vent are to purge the air during the feeding process, to purge the air from the radiators, and to get out the air pockets when there is no flow or at some specific points where it's possible to create an air pocket. The air vents are located at the highest points of the system, at all the highest points of the system, and not of the pipes. Now let's talk about the air and dirt separators. So the range is called Xstream and Smart. So the purpose here is to evacuate the microbubbles. So even if we focus on the air, a dirt separator is required. That's why you can see here a dirt separator and the combination between the air and dirt separator. Removing the air leads to much less sludge into the network, but there is still a little amount of sludge to get out, so it's necessary to have a dirt separator every time. So two ranges of product, the Smart and the Xstream. And here we we focus on the little bubbles. So on the left side, you can see the Xstream solutions. The size is up to 50 millimeters for the pipe connection. The air separator is the Xstream vent. There is an air vent at the top. Here you can see the big air separator, which is called Flamco Smart. There is also an air vent at the top of the product. The dirt separator, so the small one is the Xstream Clean, and the big one made of steel is called Flamco Clean Smart. There is a draining valve at the bottom of the product, and the air and dirt separator. So the small one is the Xstream Vent Clean, and the big one made of steel is the Flamco Vent Clean Smart. There is an air vent at the top and a draining valve at the bottom. The size for the product made of steel, so the big products, is from 50 millimeters to 600 millimeters. Let's talk about the functions of this kind of product. Regarding the air, the function is to trap the air bubbles from the water and to get out this air, so to create an air pocket and to get out the air through the air vent. Regarding the dirt, it's also to trap the dirt particles, so the heavy ones, the light ones and the magnetizable particles in order to drain them out. So this product works when the network operates. About the location in the system, the air separator is ideally located after the boiler because the water is hot, so less air can dissolve into the water and there are plenty of bubbles. The dirt separator is before the boiler in order to protect the heat exchanger of the boiler. And in the case of the air and dirt separator, it depends. If you prefer to protect the boiler, so the separator will be located on the return pipe. But if you focus on a preventive system, so if you focus on the air, the separator will be located after the boiler. In France, for example, it's mainly installed before the boiler. As this product is very smart, I'm going to explain the way of operating. You will judge by yourself. You can see on the right-hand side a cut of the air and dirt separator with the air vent at the top, the magnet here, and the draining valve at the bottom. In the middle, you can see the circuit of the water across the bottle. So the water runs from the left side to the right side, and you can see two arrows in black here. With this arrow, these arrows mean that 10% of the water flow is derivated to the separator. As the velocity drops, the particles of sludge and the bubbles can move to the top and to the bottom of the separator. So to the top for the bubbles and to the bottom for the particles. There are also suspended particles. They can also be removed thanks to the valve you can see here. The clean water goes back to the pipe by the small tube you can see here. There is a Venturi effect and the water velocity is very high. As a result, the air bubbles and the particles in the water are pushed against the side walls and are driven with the derivative flow. 40% of the bubbles and the particles are driven by the 10% of derivative flow. It's very efficient. It's a continuous treatment. And so there are many added values for this product. A very low pressure loss, so no need to change the pump operating settings. It can be used for the new and the existing buildings. The DN of the separator is a way to select the product. There is no additional power supply, no pump, no added energy is required to make the separator work. And there is no maintenance, but open sometimes the draining valve. So it's a very convenient product in order to clean the network. It's very easy to install and it's very easy to use. The last product I would like to talk about is the degasser that is called the VacuumAt Eco. The purpose is to remove, to evacuate the dissolved gas. The VacuumAt is very useful for the big installations. It enables to save a lot of maintenance time to purge the network. So you can see the VacuumAt Eco with the controller here, the screen here, the bottle of the VacuumAt, the air vent at the top, and the pump. It's a variable speed pump. The VacuumAt is used to to get out the dissolved gas of the installation. It can treat the filling water and the top-up water. It's located on the return pipe, mainly in order to operate at a lower temperature. The vacuumat starts a degassing cycle every 7 hours. So let's talk now about the way of operating. On the slide, you can see the return pipe here with the operating pressure. The bottle of the vacuumat is here, the vortex that helps to create the bubbles, the pump, variable speed pump, and the flow limiter here. First, the pump starts with a high speed. As there is a flow limiter here, the amount of water that gets into the vacuumat is lower than the amount of water that gets out of the vacuumat. So the pressure decreases and a lot of bubbles form. That's the same when you open, when you remove the cap of a bottle of sparkling water. It's exactly the same thing that occurs. So some air bubbles are forming, and after that the pump speed decreases in order to create an air pocket at the top of the bottle, and the air vent can evacuate the air pocket. As there are sensors at the outlet here, as long as there is air coming out, it goes on. And after that, the system stops for 7 hours. The product is very interesting because thanks to the variable speed pump and the temperature sensor, the vacuumat knows the water boiling point and doesn't decrease too much the pressure in order to avoid the boiling point. Indeed, if the water boils, we don't evacuate air anymore, but water vapor. It's not the goal at all. So to sum up, what I described, what I said about the pieces of equipment, 3 types of products to evacuate the air because there are 3 forms of air. First, the air vent. Don't forget that the air vent operates only when the installation is not operating. So when there are air pockets into the network at the highest points. We talk about the air and dirt separator for the small bubbles. So the product can trap the air, the bubbles, in order to create an air pocket and to evacuate the air. And we also talked about the degasser in order to evacuate the dissolved gas. And the degasser can also be used for the filling water and the top-up water. Don't forget that even if all these equipments, these pieces of equipment, we are going to remove a very big amount of air from the network, so less maintenance at the end. We still need a dirt separator. That's why here you can see the air and dirt separator. There is still a small amount of sludge due to the water compositions or for other kind of corrosion, things like that. But it's a very low amount of dirt and sludge when we focus on the air. So a word now, in order to go further with this sludge issue into the network. We said previously that the air may enter into the network through the fittings, the valves, the pumps, so all the connections. And we can't prevent that. So that means air is going to enter into the network, so oxygen is going to enter into the network. And as soon as the oxygen can enter into the network, that means it can react through a corrosion reaction, and it's going very fast. So we need to trap the oxygen before the corrosion reaction. So we need a chemical product in order to react with the oxygen as soon as it enters into the network. So we also talk about acid corrosion. That means the pH for the water pH, for example, is something very important, and we have to set the pH value in order to avoid the acid corrosion. There is not only the pH to set, but there are also other parameters, but it's just an example. So that's why if we want to be very efficient, the water needs to be conditioned. We need we need to condition the water carefully in order to set the pH value and to have chemicals present into the system in order to trap the oxygen. This product may be the Sentinel X100. It's an example of chemical product to set the water characteristics into the network. As a conclusion, I would say that think about hydronic flow control, so COMAP, FLAMCO, and also Sentinel to help you with the water quality of your networks and with the network itself. Hydronic flow control can offer the suitable products and also the expertise in order to have a very good network in a good way of operating. So this presentation is finished, and I thank you for following. I wish you a very good day. Bye.